Okay, in this video we are going to determine the equation of the tangent to f at x equals to 3x squared minus 2x plus 2 at x equals to -4. In order for us to understand this, I suggest we first draw a rough sketch. Let's draw a rough sketch. This will be the parabola. If we were to sketch this graph roughly, it will look like this. And then somewhere along this parabola at -4, we have a point where we will have a tangent, because they are saying at x equals to -4. We will have a tangent. But we know the x value is given as -4. So what we are trying to do is to determine the equation of this tangent. But to do that, we will need to know the gradient at x equals to -4. How are we going to do that? We are going to use f at x by finding the first derivative. The first derivative is going to be 2 times 3, that is 6. We take away 1, that will be x. And then we say 1 times 2, -2, it's -2. We take away 1, then x goes away. The derivative of a constant is 0. This will be the derivative. What do we know about the derivative? Is that it defines the gradient at any point along the curve, as long as you have an x value. And in this case, we do have an x value, it's -4. So to calculate the gradient at x equals to -4, we are going to say the gradient is equals to, at the derivative, we are going to substitute this -4. So what's the derivative? It's 6 into -4 minus 2. And then we know the gradient now. The gradient is going to be -26. The gradient is -26. Now we are looking for the equation of a tangent, which is a straight line, which means we are going to use y equals to mx plus c. We have the gradient now, because we know it's -4. The curve and this straight line, which is a tangent, they share the same gradient. It's x equals to -4. So we need a point. We need the corresponding y value. How do we find the corresponding y value? The point of contact. I like to call it the point of contact. How do you find the point of contact? You find the point of contact by saying -4, because -4 is given. You take -4 since it's an input. How do you find an output? You substitute it on the original function, which is f at x. Okay, this -4 is along f. So if you are looking for output, you substitute to f. So this is what defines the point of contact. So it's going to be -4 is 2, and then you substitute -4, of which is going to be 58. Now we have 58. 58. Okay, and then after substituting this -4 to f, you will get 58 as your y corresponding value. So we know the point of contact now. And then you go back here. We have the gradient. We have the gradient of -26, and we have a point of contact. Then now it will be easy to calculate the equation of this straight line, which is the tangent. So let's do that. Instead of y, we are going to put 58. Instead of x, we are going to put -4. Then instead of m, we are going to put -26. Then let's do that. This will be 58 is equals to, instead of m, it's negative 26. Instead of x, it's going to be minus 4 plus c. This will be 58 equals to negative 26 times negative 4. It's going to be 104 plus c. And then it's going to be 58 minus 104 is equals to c. Then therefore c is equals to 58 minus 104, which will give us negative 46. Now we know that the equation of a tangent is going to be, what's the gradient? Negative 26x minus the value of c, which is minus 46. This will be the equation of a tangent at x equals to negative 4.